Okay girls, today we're going to be doing conditional probability, okay? That's when questions ask you, find the probability of something happening, given, that's a symbol for given, B has already happened. Let's have a look at example 15 to illustrate that. It says all 30 students in a class study either history or geography. If 18 only do geography and 8 do both subjects, find the probability that a student does geography, given that the student does history. So if we're trying to find the probability of a student does geography given that the student does history, that means find the probability that a student does both geography and history, which in this case is obviously 8 because that's a number in between history and geography. Now, what's it out of? It says find the probability that a student does geography given that the student does history. So that's a number at the bottom there, given that the student does history. So how many history students are there altogether? Well, under the history circle, that's 4 plus 8. So that's the number that goes at the bottom, okay? And 8 over 12 is 2 over 3. So if I was to write this question in terms of the symbols that I've introduced here, this is how you could write it. Find the probability that the student does G for geography, given that the student does history, okay? And then on the top, you write the students that do both geography and history over the probability of students that does history. So this is the formula, okay? When it comes to given questions, the top number is your AND number and the bottom number is the given number, okay? Let's apply that in example 16b now. It says the table shows the results of a survey into vaccinations against a new virus, okay? Find the probability that a person selected at random, question B only, infected, given that the person is vaccinated. If we look at the table here, we can clearly see that the number of people that are infected, given that they're vaccinated, is 13, infected and vaccinated. So the answer is, in terms of symbols, infected I, given that the vaccinated V, would be 13 out of the total number of people that have been vaccinated. And from the table, we can see that that's the bottom number here, the total, 240. So that's your answer for that. Now, example 17 is what I really want to go through and onwards. Okay, let's have a look at this lengthy problem. Lara is an athlete who enters a swimming and running race. She has a 44% chance of winning the swimming race and a 37% chance of winning both races. Find the nearest whole percentage, the probability that she wins a running race if she has won the swimming race. Right, in order to do that question, let's always look at the last sentence of the question. It says find the probability that she wins a running race, so R, given she has won the swimming race. So that's how you set the question up. You always look at the last sentence of the question and then write the full formula out. So then the top would be probability of running and swimming over the second letter, which is swimming. And then you just have to look for these numbers. What's the probability of her winning both running and swimming? It says 37% chance of winning both races. So write 0.37. You always want to write the percentage as a decimal. And what's the probability of her winning swimming? It says 44%. So that's 0.44. Okay. Put all these in the calculator and then convert it back into a percentage. That's 84%. All right, let's have a look at example 18 now. Similar problem, but a bit more confusing. It says a zoo has a probability of 80% of having an article published in the newspaper when there is a birth of a baby animal. When there is no birth, the zoo has a probability of only 30% of having an article published. The probability of the zoo having an animal born at any one time is 40%. Find the percentage probability that a baby animal was born, given that an article was published. Okay, here's my tip to you girls. It's a very confusing problem because you've got all sorts of variables here. If the question has 3 percentage numbers, okay, start by drawing a tree diagram. And when you draw a tree diagram, start by drawing it from the last sentence of the description, okay? So let me explain what that means. In the last sentence of the description, it says the probability of the zoo having an animal born at any one time is 40%. So you want to start with that. So probability of having an animal being born and not born. And I'm going to put a dash for that. And for born is 40%, so that's 0.4. And not being born is 60%, which is 0.6. All right, so once you've set that up, now let's go backwards. If there is an animal that has been born, it says a zoo has a probability of 80% of having an article published. So we can have the article published, an article not published, and it says 80%, and then that would be 20% here. Now let's have a look at a scenario if the baby animal is not born. The probability of having an article published is 30%. So having an article published will be 30%, 0.3, and not published is 70% then, okay? So once you've set that up, let's have a look at the question now. Find the probability that a baby animal was born. So baby animal was born, B, given that an article was published. So that would be the question here, all right? Once you've set the question up, write down the full formula. So we want the numbers for baby being born and article and over the article, okay? So in order to get this number, use a tree diagram. So that would be, if I write down all the outcomes, we've got BA, B not A, not born and A, not born, not published. So this number would be this, which means that times that. Okay, and for the number here, anything with an A at the end are the numbers that you want to actually add them up. So this times this plus this times that. If you put all of this in the calculator, you'll find you get 64%. Okay, so this is how you do that kind of problem. All right, so I would like to show you girls one more problem like this just to re-emphasize what I've done. Let's have a look at question 15 now. A tennis team has a probability of 76% of winning a match when they're at home and 45% of winning a match when they're away. It means winning a match when they're at home country. If the team plays 58% of the matches away, find the probability that the team wins the match given that they're away. All right, so once again, it's got three percentage numbers. Let's look at the last sentence of the problem. If the team plays 58% of the matches away, so that means we can have the team playing matches away or at home. And if they say 58% is played away, so that's 0.58, which means at home would be 100% take away that, which is 42%, okay? If they're away at home, it says the chance of them winning a match. When they're away from home, it says 45%. So there's 0.45 there. That means losing would be 55%. Similarly, if they're at home country, it says the chance of them winning is 76%. That means them losing would be 0.24%. So that's how you would set the problem up in order to do this question, okay? All right, now, let's have a look at a situation when the events are independent. All these questions that we've been looking at, they're all dependent events because as you can see, for example, the probability of getting something article published is dependent on whether a baby animal is born or not. It's dependent. But what if it's independent? Okay, let's have a look at what happens. We learned from last lesson, if we want to find the probability of A and B happening, you multiply the two probabilities. Let's apply that in our formula that we've learned here. So if I rewrite all that formula again, because this is equal to this from what we've learned, let's replace that top with that and let's see what happens. So I've got P of A times P of B over P over B. And as you can see from looking top and bottom, these two are the same. So that implies probability of A happening given B has happened is the same as the probability of just A. This is the case when events are independent. So for example, a question could be, what's the probability of rolling a 2 on the second die given the first die was number 3? Okay? And the answer to that is just a probability of one of them. All right? So we now need to use that technique in one of the examples. Let's have a look. It says the probability of X is 0.2, the probability of Y is 0.6, and the probability of X and Y is 0.06. Are the events independent or not? That's the question. So what you want to do is just basically multiply the two events, okay, and then see if that's the same number as X and Y. So you'll find this is 0.12, which does not equal to 0.06. So that means the two events are dependent. Okay? Let's have a look at this question though. It's slightly different. They've given you the probability for A and B, but in this question, they've given you the probability for A or B. In this question, they've given you the probability for X and Y. So in order to do this question, girls, let's go back to what we learned in our first exercise. We've learned this. Yeah, remember that? So let's apply this here. So we know this number, 0.78. We know that number, 0.6. That number is 0.45, and that's what we're trying to find. The reason why we're trying to find this is so that we can do exactly what we've done there. So if I find the probability of A and B, that would just be 0.78, take away that, divided by -1. If I do that, answer is 0.27. After you've done that, let's now multiply these two events and see if I do get that. If I do get that, that means the events are independent. So let's have a look. So multiply now. If I put this in the calculator, you'll find it is 0.27. So because these are the same, that means A and B are independent. Okay? So girls, that's how you basically do this exercise questions. Let me know if you have any questions after all this and give the exercise a go. All right? Thanks, girls.